All right, so today we're going to talk about the FTC again, but we're going to refer this theorem to particle motion problems, and also we're going to talk about the average value. So you can see there are three very important statements here. So the first one, I don't want to copy it, but well, I guess I will. Okay, so you see that the integral from a to b and the v of t dt. So v in this case represents the velocity, and when you apply the FTC in this case, if you remember, the velocity represents the derivative of the position, and the FTC says that the integral of f prime basically dx equals f of b minus f of a, where f of x is the antiderivative. So in this case, our antiderivative would be the position function. So it's either s or p of b, b minus p of a. Okay, that's not hard. And the second one, again, we have an integral of v of t dt. And notice there's no absolute value around v of t. When you see the integral from a to b v of t dt, remember that, basically here we talk about the net distance. The particle travels on the particular interval, in this case, between A and B. And remember that velocity is always positive. If the velocity is always positive, v of t is greater than 0 on that interval, then you can also say that it's not just the net distance, but it's actually the total distance. But if you do want to find, by the way, let me just write down, it's the net distance. Now, if you actually want to find the total distance, and please remember the basic formula is an integral of v of t dt, but you need to consider the absolute value. Because even if your the graph of the velocity, appears below the x-axis, and it just tells you that your object moves to the left, but it's still moving, right? So if you remember, we discussed this. In order to find the total distance, you need to just take the absolute value of all of those pieces. And I'm just going to put the total distance. Okay, so these three facts are very important, and basically there's nothing really new, nothing fancy here. Now let's see how we can apply these facts to different situations, different problems. The first one, it says the velocity of a particle that is moving along the x-axis is given. So v of t equals 3t squared plus 6. Now they tell you if the position of the particle at t equals 4 is 72. So I don't want to put is 72. So what does this expression mean? If the position of the particle at t equals 4 is 72. So algebraically, how would you write that? So position, you know what, I actually prefer s when I talk about position. I always use, my function. For my function, I always use the letter s, variable s. So it says at t equals 4, so s of 4 equals, and it says 72. Now, they're asking you, what's the position when t equals 2? So they want you to find s of 2. Now, since the velocity is given, and you need to find the position, then of course we're going to integrate. So we're going to say the integral. So what are the boundaries? We're talking about 2 and 4. v of t dt. Based on the FTC, it's supposed to be s of 4 minus s of 2, correct? So do we have a v of t? Yes, of course, we do have it. So we have the equation, and it's right there. It's 3t squared plus 6, please don't forget dt, s of 4 of, I'm going to plug in later, minus s of 2. Let's integrate. The integral of 3t squared is 3t cubed over 3. The integral of 6 is 6t. What are the boundaries again? 2 and 4. So we're going to plug in and see what happens. So we get 4 cubed plus 6 times 4, that's 1, minus 2 cubed plus 6 times 2. 4 cubed is 64 plus 24, 88, right? Minus 2 cubed is 8 plus 12, that would be 20, I assume, and that's 68. So this integral, the value of this integral equals to 68. Now it says s of 4 minus s of 2. But what is s of 4? We have it. It's right here. It's given. It's 72. So s of 4, 72, minus s of 2. That's what we're looking for. Well, the rest of it is easy, algebra 1. So s of 2 equals 72 minus 68, which is 4. And we're done. Now they're asking you, part B, to find the total distance. That's very important, not the net distance. Total distance from 0 to 7. And how do we find the total distance? We integrate from 0 to 7. And normally we use the absolute value, right? That's how you express it. But you know what? Since the velocity equation is 3t squared plus 6, which is always positive no matter what. The t is greater than 0, so whatever you plug in, you always get positive value. So your graph is above the x-axis. So then you can, we ignore the absolute value sign, and you can just integrate from 0 to 7, 3t squared plus 6. And you get, we already did it, remember? It's t cubed plus, remember here, plus 6t. It's just the boundaries are different. So we get 7 cubed plus 6 times 7, that's 1, minus 0 cubed, that looks kind of silly, you don't have to do that, and that's 0. So 7 cubed plus 6 times 7, I'm using my calculator here, and it is 385. So we're down here. All right, so next question number 2. The velocity equation is given again. It says if the position of the particle at t equals 1.5 is 2.551, you know what, I'm just going to rewrite it. So the position is given. So S of, and what's the time? 1.5. And what's the position at that time? 2.551. Okay, that's given. And this is what's the position when t equals 3.5. So we need to find S of 3.5. But isn't it kind of the same problem, same type of problem? The only thing is we're allowed to use your calculator, and actually I hope you have your calculators in front of you right now. So here's what I want you to do. Well, first of all, let's write it out. So the FTC, since we have to find the position, so we're going to integrate our velocity. So what's the equation? 0.5 e to the power of t t minus 2 to the power of 3, and we are between what and what? 1.5 and 3.5. Those are the boundaries. And based on the FTC, that would be S of 3.5 minus S of 1.5. Now it's a calculator question, so please take your calculator. I'm going to take mine. Clear everything, make sure you don't have anything on your screen, and you're going to do math 9, and for the lower boundary you're going to put 1.5, and for the higher boundary you're going to put 3.5, and then you're going to enter your whole function. You can pause if you want and just do it. And and after you enter your whole function, where it says, by the way, D and then it's blank, don't forget to put X, press enter, and you are going to get, I got 15, hopefully you got the same thing, 919. And the position at 3.5 we don't know, so I'm going to use the same expression, minus S of 1.5, and that's given, and that's 2.551. So again, very simple, add this to both sides, and you get 18.470. And notice we don't use any units. The units are not given, so we're okay here. On part B, for part B, it says find the total distance again. Now, I don't know what my graph is going to look like, where the velocity graph is above the x-axis, below the x-axis. Obviously, something is happening here, and we don't want to waste our time and graph on the calculator. We are going to use our formula in order to find the distance, total distance, and it says from 1 to 5, so the boundaries are given. We need to consider the absolute value of the velocity, right? So that's our total distance. So again, we're going to use our calculator. Let me just enter my, write down my function, t minus 2 to the power of 3, absolute value, and dt. I don't know if you remember, in order to find, in order to enter the absolute value on your calculator, you need to go on math to the right, numbers, and then number 1. It says abs, ABS, and parentheses. So press enter, and you get your absolute value sign. So you can pause, do it, and I already did it, and I got 913.067. Problem number 3. Next question. They give you this graph, and by the way, this represents the velocity, very important, not the position. And also it says that the position of the particle at t equals 8 is 12. So S of, or P of 8 equals 12. That's good to know. Now use this graph to answer the questions. And question A says, what's the position of the particle at t equals 3? All right, so we have our boundaries, right? So time is 8, time is 3. We're going to use the FTC. So same stuff. So integral from 3 to 8. Since we have the velocity, we integrate. V of t dt equals, and the FTC says if we do S of 8 minus S of 3. Correct? All right, now the question is, we don't have any equations. We don't have the equation that represents the velocity. All we have is this graph. But how do we find this entire integral? Well, if you remember, the integral is what? The area under curve. So what are the boundaries? 3 and 8. So we are between 3 and 8. And we need to find this area. So we're going to consider this piece and that piece. So, geometry. I see a trapezoid, so I'm going to do 1/2. The trapezoid is above the x-axis, so the answer is going to be positive, the value of my integral. So 1/2, one base plus another base. So this piece right here would be, well, you're looking at your paper, so it's clear when you have the actual graph. Here it's a little bit messy, so I believe this is 1 unit long. Yes. So yes, 1 plus, and this one is 3 units long, 3 times the height. And the height is, this whole green line is 5, right? Okay, that's our trapezoid. Plus, this triangle, the little triangle, it's below the x-axis, so that means the answer is going to be negative. I understand the area cannot be negative, but we talked about it, remember? We're talking about the integral, and the value of the integral is negative because your graph is below the x-axis. So minus area of triangle would be 1/2 base times height. This distance is 2. And the height is, look at your graph, please. It's really hard to read mine. I think the height is 2 units long. Yes. So we get 1/2 times 4, 2 times 5, 10. Minus, here on this side, this cancels out, so we just get 2. And the answer is 8. I'm just gonna circle that, box it for myself. Now the FTC says you do, let me just get rid of this part right here. We already solved it, so we don't need it. And the FTC says this, the value of this integral, and we found it, it's 8. And 8 equals s of 8 minus s of 3. And s of 8 is up here, it's given, 12. Minus s of 3, we don't know what it is. Now, to find s of 3, we're going to do 12 minus 8, which is 4. So we're done. And by the way, I just noticed the units are given, I think, or not. The graph of the velocity, yes, measured in feet per second. So that's a very bad mistake. So that means we do need to use units at the end. So the position at 3 equals 4 feet. Okay. So for part C, this is what I got. I hope you got the same thing. And part D, it says midpoint, Riemann sum, 3 subintervals. So if you remember, we had 0, 3, 6, 9, 12, 15, and 18. But we need to consider the midpoint, so that would be in 3 subintervals. So if 3 subintervals, then it's this rectangle, and then second, no, that looks silly. That's not right. 1, 2, 3, 4, 5, 6, and that's 1, and that's 2, and that's 3. Okay, so I'm going to use different colors. That's the second rectangle, and that's the third rectangle. And the midpoint Riemann sum. So we're going to use what points? This one, and this one, right? Because those are the midpoints. Now let's write it out. The integral from 0 to 18 v of t dt equals, nope, not exactly, length times width, so that would be 6 times f of 3 plus 6 times f of 9 plus 6 times f of 15. And that gives us f of 3 is 2.7 plus, you know what, let me just factor out this 6. That will be better. Plus f of 9 is 1.3. And the last one is 1.7. Use your calculator. And I just did. And I got 34.2 meters. And we're done. I don't really think this is hard. So hopefully this makes sense. You know how to find me. Let me know if you have any questions, and I will see you tomorrow. Thank you.